We're now going to work on learning how to construct basic visuals in Power BI. I've put together this table which lists the inputs that are required to construct each of the different types of charts listed in the first column. We won't cover how to create every visualization that Power BI allows. These are common ones we'll be working with. Now, you shouldn't need to rely on this table to know how to build visuals, but if you really struggle with knowing where to start, you might consider pausing the video to take a screenshot of this for reference. In this video, we'll start with the highlighted chart types. We're going to start with a data set that is somewhat familiar to you, the car dealership data from case 1. This data was stored across 5 related tables, such as purchases, sales, customers, and so forth. And if you recall, you had to do around 8 different VLOOKUPs or XLOOKUPs to retrieve values from one table and put them in another. What we're about to do in Power BI is a pretty slick way of dealing with relational data. So open a new report in Power BI, and we're going to connect to the first file in our lecture materials, an Excel workbook called Dealership Data. We'll hit open, and as you can see, there are 5 sheets of data in this file. Let's check all these boxes. We don't need to apply any transformations, so we're just going to load the data. And after loading the data, we can see that these tables are now listed on the right-hand side of our screen in our data pane. And clicking these drop-down arrows lets us see the fields contained in any given table. On the left-hand screen, let's toggle to Table View to take a look at the data. We can't really edit the data manually here. This is just a preview for each of our tables. But if we ever need to transform the data, we can right-click on any of these table names and click Edit Query to launch Power Query. Lastly, let's go to Model View. This time, our data does consist of multiple related tables. And at the time of importing this data, Power BI employed a procedure to automatically detect relationships between these tables. Part of the algorithm is that it goes through each of these, it scans for columns that contain entirely unique values, it looks at the names of columns, and makes a determination whether primary key, foreign key matches occur across tables. And as it detects these matches, it establishes these relationship lines. Just to review what we've learned about data modeling, each square that you can see here is a class with various attributes listed below. Lastly, we see association lines connecting related classes. But when we're talking about the actual data or a relational database, we would call each of these squares a table, which contain fields that it may exhibit relationships with each other. Now, one very important thing to do is to set the cross-filter direction for these relationships before proceeding. This is a quirky thing that I've only seen in Power BI, but if you click any triangle in the middle of these association lines, this will now display the properties of these relationships. We've got some information that you probably recognize up here, but the important one we need to change is right here, cross-filter direction. For all of these, we need to change this from single to both, and don't forget to hit Apply Changes here. You'll see the triangle is changed. This is now a bidirectional cross-filter. This setting relates to the direction from which data is allowed to flow between these one-to-many relationships. The default that Power BI uses is single, which is efficient for performance, but to properly aggregate the data in multiple directions, I need to change cross-filtering direction to both for all of these relationships. I can't overstate how important this is. Please always remember to change the cross-filtering of all your relationships to both at any time that we are working with multiple tables. Let's go back to Report View now. The first type of visual we'll work with is what Power BI calls a matrix. Essentially, this is the same thing as a pivot table in Excel. So if you go to the Visualizations pane, let's select this option that looks like a table with a blue column and row in it. This is the matrix button. And like I've said before, my preference when building visuals is to start by selecting the type of chart I want and then adding the required inputs. So I click it. One of your requirements in case 1 was to list the average sale amount by vehicle type. To find these fields, we'll want to expand each of these tables. And this already gives you a sense that being familiar with your data, knowing which tables host which fields, is going to be pretty helpful here. The field I want to summarize is sale amount, which I can find in the sales table. I will drag and drop this field to the values box in the visualizations pane. I want to summarize this field by vehicle type, and this field is stored in the products table. I'll drag this to the columns. Let's expand this out. We're almost there. You'll notice that the default summary metric is to sum up the numeric values for sale amount, but I want to display the average sale. So let's go to sum of sale amount in the values box, and I'll click this drop down arrow, and you can see there are various options for what we can do with this field. But what we want to do is change the aggregation method to average. Great. Let's try another one, but this time we'll use multiple dimensions and impose a filter. You may also recall that one of the case 1 requirements was to determine whether all counties were in compliance with a new credit policy that the company enacted in September of this year. Specifically, the new policy prohibited the sale of vehicles to customers with credit scores below 600. So now we want to present the lowest credit score for sales associated with each county by month. So I'm going to click outside of this visual, don't want to select it anymore, and I'll click the matrix button again to start over. I'll set the columns to be county, which is found in the salespeople table. The values will be credit score from the customers table, and immediately I want to change this from count to be the minimum. Lastly, I'll drag and drop sale date from the sales table to be our rows. This is our first time including a date variable here, and now is a pretty good time to talk about how Power BI handles and summarizes dates. When you add a date field to a visual, like a matrix or line chart, Power BI typically displays the date field as a hierarchy, and this hierarchy has the following levels: year, quarter, month, and day. In a matrix visual, Power BI will show your data first grouped by a year, this top level, with the ability to drill down into quarters, months, and days. And there are 2 buttons to be familiar with to look at different levels, so please pay careful attention to what I'm about to say. First, let's consider this button right here that starts as 1 line and branches down into 2. The hover over text reads, expand all down 1 level in the hierarchy. I'm going to say that this is the button you're going to want to use most of the time. As I click it, we go from years to quarters, but still preserving which year these quarters came from. Now, this underlying data set was only 1 single year of data, but if it spanned multiple years, more than 1 year would be displayed. We can keep drilling down to see what the data would look like at the month level, and even the day. Now, this is probably too granular, but what I want to draw your attention to is that this line right here, this is summarizing data from January 1st, going back to the highest level of the hierarchy, the year 2024. And I assume this is probably what you're expecting, and so you're probably wondering why I'm making such a big deal about this. Let's demo the other way of drilling down. I'm going to click this up button a few times to get back to where we started. This time, I'm going to click these parallel lines with down arrows. The hover over text says go to the next level in the hierarchy. When I click it, it provides the 4 quarters, and so far this data looks identical to what we saw before. One little difference is we no longer see the year 2024 as a header at the top. Now listen carefully. If this data had spanned multiple years, this would be summarizing the data for Q1, Q2, Q3, and Q4 for all years in the sample period. It's no longer specific to the year 2024. It would be showing what the minimum credit score is for any Q1 in any year. So if I click it again, it shows us the months, summarizing the data for a given month across all years, and I hope it finally clicks when we reach the day level. This time, we do have a date hierarchy level that does repeat within a year. This now shows the minimum credit score for sales occurring not just on January 1st, 2024, but across all dates whose day number happens to be a 1. Or the next line, these are the lowest credit scores for any transactions that took place on the 2nd day of any month in the sample period. We'll revisit this topic when we hit line charts, but I just want you to be aware of the difference between these 2 buttons and make sure you're using the one that you need. I'm going to drill up to the top one more time and use our preferred button here to get down to the month level. Since our focus is just on the month of September and thereafter, I'm going to go to our filters pane, find sale date by month, and restrict the presented results to only the relevant months. I don't want to display the different quarters, so I'm actually going to hit the X next to quarter and sale date. One final thing I'll show before proceeding to bar charts is how to apply conditional formatting in Power BI. Maybe I want credit scores under 600 to be highlighted in red. So I will go to min of credit score in my values, click the drop down, and toward the top we've got conditional formatting. We'll hover over it and I think I'll select background color. This provides us with some default formatting suggestions, using a gradient of different blue colors where the higher a number is, the darker it becomes. I'm going to change the format style from gradient to rules, but notice it's now changed the aggregation method back to count. But I don't want different colors based on how often a value for credit score appears in the data. I'm going to change the summarization method from count back to minimum. So let's read through this rule. If the value for min of credit score is greater than or equal to 0 and less than, well, I don't want this to be 0, I'll change this to 600, then, and we can change this light blue to be a more sinister red color, then it will apply this formatting to the background. I hit OK, and very quickly we can identify that it was the Salt Lake location violating this policy. And there you go, an alternative way that we can arrive at the case requirement from before. And like Power Query, these are live connections to the underlying data. If we leave this visual as is, and our data files keep updating, our visuals will also update, which is pretty neat. Let's move this matrix up a little bit, and we'll start practicing building bar and column charts. Again, Power BI likes to call bar charts only those with a horizontal orientation, whereas column charts are those that are vertical. So I'll click out of this to deselect the matrix. Suppose I'm interested in understanding how my sales vary by manufacturer for a few of my smaller locations. I'll start by creating a stacked column chart, the second option in my visualizations pane. Since this is going to be vertically oriented, I need the different groups to span the x-axis. So I'll drag and drop county, again in the salespeople table, to my x-axis. The field I want to compare by county is sale amount, so I'll bring that to my y-axis. Within each of these counties, I want to see how much of these sales the various manufacturers make up. So I find make in the products table, and I'll bring that to legend. Let me move this up here and we'll resize it a bit. Now we can see that the Salt Lake location has the grand majority of this company's sales. So I'm going to find county in my filters, and I'm going to deselect Salt Lake and Utah. So now in this stacked column chart, the raw dollar amounts from different makes are literally stacked on top of each other within each county. This lets me see that the total sales for, say, Weber County are roughly $2.5 million, but sales of Chevy vehicles is roughly $1 million, all the way up to Toyota, which has roughly $400,000. Notice, we now have 3 visuals on this single page. And remember, they are all connected back through the relationships that were set up in our data model. So when I click one of the vehicle types in our first matrix, I'll do sedan. The column chart has updated to highlight the proportion of revenues in each category that relate to sales of sedan body types. The credit score matrix has also updated to only show the minimum values for sedan sales transactions. So we can already see that whatever Salt Lake sold that violated the policy from before must not have been a sedan. To get rid of this selection, you just need to click on any white space within the original visual. So I click here, and we're back to where we were. I could similarly click on a month in this matrix. And this now highlights sales transactions that took place during the month of September. Or if I click on the Weber location, this highlights only the Weber column over here, but notice it doesn't have everything. This still retains the filter to highlight sales in Weber County, but only during the last 4 months of the year. So I'll click the white space in this visual to deselect it, and I'll click out of this selection. Let's now manipulate this column chart. We need to click to select it, and we can now toggle across different types of visuals. For instance, if I want this to have a horizontal orientation, I could click the first option to have a stacked bar chart. Maybe that's easier to look at. Or if instead of stacking these, I could use a clustered column chart to have separate vertical bars for each manufacturer within a county. Each of these options is still presenting it in terms of raw dollar amounts. Lastly, if my focus was less about the total amount of sales dollars and more about the relative proportion of sales from each manufacturer, I could select one of the 100% stacked charts. I'll use the 100% stacked bar chart this time. We see that each bar is the exact same length. They all span from 0 to 100%. And the different components are roughly similar in size, but I can perceive a few differences here. Davis County seems to rely on Chevy sales more than Cache County, but less on Hyundai's than Weber. So as you can see, creating visuals is pretty simple in Power BI. We'll move on to some additional types of visuals in the next video.